I am already back. Look at that, guys. I'm crazy. I just don't stop. After a nearly 3-hour live stream. Still going at it. I need to get the live stream on my phone. So, I am live. Can I see myself? Where the heck is my actual stream? Is it starting? Or is it not starting? Are you going to work? Looks like it's working. Hello, hello. Wait a minute. Where is it? Where's the... Can I get a link? Come on, give me... Alright, why is this so hard? Switch account. Bob Saget lover. Subscriptions. There we go. Oh, hey, that's not nice. Alright, I'll be answering chat questions in the chat using Bob Saget Lover 86, so don't be surprised when that happens. I'm not going to be holding the mic this time. I apologize to all the mic holding fans. Hola. A salute from Argentina. Very nice. Do the integral. Let me look at what the integral is, because he sent it to me like 12 times. Alright. Okay, the integral. Oh my god. Okay. Epic. 2 minus x. Sorry, it's natural log. Natural log 2 minus x over 2 plus x. Nope, wrong way around. 2 plus x over 2 minus x times 1 over x times the square root of 1 minus x squared dx. Oh my god. Why would you do this to me? I'm gonna look at... what was your first step? You split it up. Of course you did. Alright, so he split it up to 2 different integrals. Natural log of 2 plus x over the x times the square root of 1 minus x squared dx, and then minus the integral natural log 2 minus x over x square root of 1 minus x squared dx. I hope he split it up into literal 2 integrals, and it's from 0 to 1. It's from 0 to 1. Alright. I have no clue where to go. I don't know why I agreed to this. Alright. Does it say, hint, try to express the integral as a function of another variable? Oh, dang. In respect to another integral. Another variable. Okay. Alright. How? Alright. I'm going to look at Black Pen, Red Pen's video on the integral of like sine of x over x, so I can remember how to do this. YouTube. Wait, he's probably giving me a hint. What is the integral of dx to the x? Integral of cosine of x over x plus 2. It uses Fourier transform. Oh! No, thank you. Let's see, Black Pen, Red Pen. I forgot how the method goes. Let me. They do it from 0 to infinity.
What's the difference?
Oh, yeah. Okay, I guess that makes sense. So, integral from 0 to 1. I'm doing blue again for some reason. You do the stupid stuff. 2 plus x, 2 minus x. Already forgot it. 1 over x, square root of 1 minus x squared. E to the minus ax? Why would you do that? Why would you do that? Yeah, for sine of x over x, try x e to the x over 1 plus e to the x minus... Oh my god. Calculate this... So many questions. So many tough integral questions. And I hate it. I hate integrals so much. You guys, you're gonna kill me. Alright. No offense to Black Pen, Red Pen. That wouldn't make... Fourier transform? The point is to remove the sine x. Wait a minute, let me look back at it.
Right? I prime of b.
The point there is to get rid of the x, so perhaps I should... This is crazy. I should try... Okay. So x square root of 1 minus x squared, I could try integrating. So that when I take the derivative, I can get rid of it, and it'd be an easier integral. What is that? So u is 1 minus x squared, means du is 2x minus 2x dx. Negative a half integral u du, square root of u du, negative a half. You get another... Oh, no, wait. That's u to the 1/2. So it's to the power of a half, you add 1, then you divide by it, which would give you negative a third. 1 minus x squared to the 3/2. Is that it? Oh my god, I forgot how to do integrals. Negative 1/2, u to the 1/2, add 1, 3/2 on the top, divide by it 2/3, u to the 3/2, multiply it by negative a half, get negative a third. U is that, yeah. Alright. So the idea I'm doing here is that that's what I'm going to put instead of x. So you have negative 1/3 a 1 minus x squared to 3/2 dx. Now this is I of A. Alright, then I prime of A, partial in respect to A. I'm not a virgin. I am a virgin. That was a joke. Okay, dx. Then I can switch it out via the Leibniz rule. And then... that was so weird. Alright. Wait, why did I... I'm such an idiot. I didn't even need to do that. I could have just done ax square root of 1 minus... Because you don't take the derivative in respect to x. Why would I... Man, I'm on a roll. Alright. So you get the idea. You take the partial derivative in respect to x there. Ooh, that comes down when you do the chain rule. And it cancels it out. You get natural log 2 plus x over 2 minus x e to the ax dx. He did e to the negative bx, and I don't know why, but I'll go ahead and then right there. Okay, what does he do?
Well, so just indicate.
E to the negative. He just integrates it. How does he do that? Over b squared plus 1. What does he say to explain that?
E to the negative bx.
I can't.
Dx,
My
right?
output's wrong.
And on the left hand side, I prime of b like that. Okay, I can fit a little bit more right here, so I will. From scratch, you can check out the video in the description as well. Okay.
Ugh. How am I gonna do that one? And it's x times the square root of 1 minus x up there. Am I doing it wrong? Okay. He didn't say I was doing it wrong. But there's no way I'm doing this right. Is it just integration by parts? Let me see. I could do... Technically, I could maybe do... Like, bring it into the imaginary realm.
Okay, we're going to integrate sine.
I'm going to integrate sine of x. Is it... Oh my god. My laptop is dying. Is it showing on stream? I can't tell. Yeah, he just does. But this isn't like cyclic. Okay, so I split this up into two different ones, I think. Like he did. 2 plus x e to the ax minus x squared dx. No, it's not gonna turn out good. That's not gonna turn out good. What am I gonna do? Alright, let's try with this. It'll be similar for the other one if this works out. So you'd probably differentiate this one and no. This is wrong. Oh God. Have mercy. Am I doing this right? I have no clue what I'm doing. I'm trying... Oh, they... What? Integrate with respect to A. What did they split it up into? They split it up into some wonky stuff, I see. Like natural log of 1 plus 1 over x. What? Ugh. Why? People will always ask, why don't you do these anymore? You have to... Am I... So wait. C de Anima Games. Are you implying that I'm doing it right? Yeah, a number theory problem would be nice. Are you implying up to this point I've done it right? I don't know. What do you mean you don't know? There's no way this is right. I'm gonna die. I'm not. It's false. 1 plus 1 over x. Integrate with respect to x, then use integrating by parts to solve. I understand that. So, I can't integrate with... I can't do it. It's too much. Alright. You get the idea. And so on. The proof from then on is trivial. I'm sorry, C de Anima Games. I'm not doing it. It's too much work. It's a 60-minute test. Blah, 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 blah. Screw you, C de Anima Games. Is there another prime apart from 29 that satisfies p to the p plus 2? So p is another prime, and that turns out to be a different prime. Would there be another one? That is a tough question. That is really... How do you even approach that? So obviously the first one's 3 cubed plus 2 is 29. How do you... So, apart from 29, come on. So I think that we should prove that it can't be done for any other value. So what's the issue with 5 to the 5 plus 2? Huh? Where's my calculator? 5 after the 5 plus 2. Is that divisible by 3? No. I don't know if there's a thing on here to find... What is that divisible by? It's not divisible by 3, definitely not 2. 7. No. 11? No, obviously not. Divide by, divide by 13. What is it divisible by? factors of 3, 1, 2, 7, 53 times 59. Those are huge prime factors. 3, 1, 2, 7. It's 53 times 59. So those... Those seem odd. Like, I don't know. What's so weird about them? Okay, let's try 7 to the 7 plus 1. Or plus 2. 8 to 3. It's divisible by 5. Alright. 11 to the 11 plus 2. It's too big. It's very big. Prime factors of 11 to the 11 plus 2. Prime factorization of 11. Wow, thank you. 11 to the 11 plus 2. It's this number. There we go. Prime factors of huge number. It is not a prime, it is a composite number. Okay. So they use Euclid's method? Final answer. It is 97 times 40,699 times 72,271. So, oh, you just, okay, so you're saying we talk about 6k plus 1 to the 6k plus 1, and we look at it mod 6, so that would be congruent to 1 mod 6, wouldn't it? Because that's congruent to 1 mod 6. So then that p to the p would be plus 2 is congruent to 3 mod 6. It would mean it's in the form of 6k plus 3, which would mean it is a factor of 3. So is that the case 1 to any power mod something? I think that's how that works. Alright. So either it's 1 more than a power of 6, or it's 5 more, multiple of 6, I mean. Alright, so that's going to be a little harder. Thanks for giving me the answer. Oh, okay, so 6k minus 1, 6k minus 1 on the top as well. So that's congruent to negative 1 mod 6. So that's negative 1 to some power, which is going to be congruent to plus or minus 1 mod 6, which would then mean that p to the p plus 2 would be congruent to 2 plus or minus 1 mod 6, which means that it is congruent to... actually, that would be an odd number. Negative 1 to an odd number would always be negative 1. So 2 minus 1 is 1 mod 6, which makes it hard. Yeah. That's the one I didn't want to get. So that one is the case of 6k plus 1, which it could be a prime. Yeah, that's not prime. It's 53 times 59, and I looked it up. So in the cases where it's 6k minus 1, there's no definitive way to talk about it, I think. Yeah. Because it could be a prime of the type 6k plus 1. So how do I know that it's just not going to be one of those? That it's not going to be prime. That's actually pretty rare, isn't it? So let's do 23 as an example. So let's see if the calculator has enough digits to do it. No. What's an earlier one? 11. Yeah, 11. 11 did not work. What's the next one? The next one's 17. So let's try 17. That's too big. Let me look up precise scientific calculator. High precision calculator. There we go. So we're doing 17 to the 17 plus 2. Execute. We get this crazy answer. Prime factors. Is it prime? Prime factorization calculator. Calculate. Do not use positive non-zero integers less than... That's annoying. Large numbers. Try an integer to factorize. So it's slow. So if the stream quality goes down, what? No, it's not a false statement because 5 is of the type 6k minus 1. So 5 is of the type 6k minus 1. I talked about examples 6k plus 1, which would be divisible by 3, unless you gave me the 7 one. Alright, so we get... Okay, so that one's not. 7 times 7 has 2 7 factors, which is weird. Wait a minute. 7 to the 7 plus 2. It's divisible by 5, but is it divisible by 3? It is! Yeah, my proof was right. Yeah, so the 6k minus 1 statement is correct. The 6k plus 1 statement is also correct. So, this is the case we have to worry about. 6k minus 1. Alright. So how does it manage to create so many... So now what if we did it at a higher modulus? So we did it at like mod 12. That wouldn't really help, would it? No, because it'd still be the plus 1. Ooh. Yeah, so, that is a really tough problem. It's probably probably not something I have the expertise to answer. Yeah. But the problem is how you can... But that's a known theorem. Wait, what? Harmonica is the smartest. Thank you, Michael. I don't agree with that, and you're going to see why I don't agree with it. That it can be written in the form... Oh! Just for primes? If it's prime. Yeah. So, if it was... so, this is equivalent to it being in the form 6k plus 1 or 6k plus 5 because of modulo arithmetic. So if it was in the form 6k plus 2, it would have 2 as a factor. If it were to have 3, if it were 6k plus 3, it would have 3 as a factor. And if it was 6k plus 4, it would again have 2 as a factor. So that's why it has to be 6k plus 1 or 6k plus 5 for primes. But the issue I'm having, excluding 2 and 3. Excluding 2 and 3. Ooh. Sorry for that disturbing imagery. How did you know your Monica's real name is Bob Calvin? What? Alright. So, this is getting on my nerves because this is a hard problem. So, So this has, it's the addition. It's that addition that really screws it all up. Just a whole bunch. The addition of 2. It's the... So this seems related to the twin prime conjecture a little bit, very loosely, because you have p to the p, which is congruent to -1 mod 6, which could also be a prime. And when you add 2, you're determining whether or not that is a prime. And so if the twin prime conjecture is false, so if twin prime is false? No, I can't do that. Yeah, because one of them could be prime and then the other one wouldn't be prime. So that's weird. So obviously, this one isn't prime, so it's not even related to the twin prime conjecture. But it is sort of related. So this one is obviously not prime because it can be factorized as p to the p. That's factorization. But when you add 2, that throws a wrench in it. So this, if this were to ever be prime, this is an example where the 2, where you have 6k minus 1 and then 6k plus 1, or, 6k plus 1. So you have this pair, and you have it that this one is not prime, and you have it that this one is prime. So you would need infinitely many failing twin primes to prove it. So if the twin prime conjecture were false, twin prime is false, that means that you would in fact have infinitely many failing twin primes. Because you only have a finite number, so here's the cutoff, then every single twin prime coming after that, which is just that form, would have to be failing. There's an infinite number of primes. And so if it's false, that means that there's infinitely many where it's true. So if but the twin prime's probably not false. So so the twin prime conjecture is probably true, but that doesn't exclude anything about infinitely many non-twin primes. So this is related to the twin prime conjecture. No, I think I oversimplified it a little bit. Did I? Yeah, I did. Because... No, yeah, that's wrong. That's wrong. It's because it's specifically in this form, so I can't really tell you about the whether it's a failing one or if it's just two random ones right next to each other. Yeah. That's really interesting, though. So one of the ones were very, very, very much divisible by 7, but I have no clue how I'd even approach that. So I could do... So if I have it that p to the p, so it's I can't do mod 7 though. So p to the p is obviously, yeah, that's a hard one. Yeah, so what would make it composite, like guaranteed composite? There would be really nothing, right? What's to stop me from saying that 11 to the 11 plus 2 isn't prime? What sticks out there? Nothing. I don't think you can really talk about that. There's gotta be like another one. Yeah, the factors of that are very mysterious. So this one's definitely composite. So a more general question to ask would be a to the a plus 2. So if a is even, obviously this would be even to n. That'd be 4n. That'd be 2n squared plus 1. And that's sort of weird because you can factor it out into an even and to an odd, like, immediately like that. So now if it's odd, 2n plus 1 squared plus 2, you could get 4n squared plus 4n plus 3. So you have 4n times n plus 1 plus 3. So I can tell you that for primes bigger than or equal to 3, that p to the p, why did I do squared? It's to the 2n. It's to the 2n minus 1. And to the 2n there still. Alright, so if I did that to the 2n, I couldn't have that. But the last term will always be a 1, so it'll be a bunch of terms, and then plus a 3. And I'm pretty sure it's guaranteed that they'd all be multiples of 4. Yeah, because it's all multiplication of 4s and 1s, and adding them, which preserves 4ness. So I can pretty confidently tell you this is going to be congruent to 3 mod 4. And so if we, plus 2 I mean, for odd primes, p to the p plus 2 is equal to 4k plus 3 is equal to 6k minus 1, or m. So I don't think that's really interesting, is it? Yeah. Anyone in the chat have any ideas on this one? Because it's congruent to 3 mod 4, those primes have a property, don't they? When they're congruent to 3 mod 4, are those the ones that are sum of perfect squares? Sum of perfect squares primes. Fermat's theorem on the sum of 2 squares. 4n plus 1. It's the other one. If and only if. If and only if. So, a really strange way you could prove that it's never going to be prime again is if you could prove that every one of these would be the sum of 2 squares. Because then it would contradict the, if and only if. Yeah, because then it'd have to be composite and congruent to 3 mod 4. Like, 11, 15. Like, 15 is not the sum of 2 squares. Okay, let's see your easier problems. 29 and 26. I don't know, they seem like quickies. 29, formal definition of limit. There's a well-known fact that, yeah, well-known. There's a well-known fact that, for real, find the value of blank. Yeah, you kind of blocked it out a little bit there. Alright, let's look at 29. Alright, we'll take a break from this one. I'll leave it up in the corner so that anyone brave enough can delve into it a little further. Alright, Alright. 29 says the formal definition of the limit is that blank, whatever. Use this definition for lim to find the largest value for delta such that satisfies epsilon equal to 1. It's a really easy question. Alright. So limit as x approaches 5. Yeah, 5. X squared plus 15x plus 50. Obviously, if you just plug it in, it'd be 25. Oh, a lot of values. Alright, 25. 75? 75. 25 plus 75 is 150. To find the largest value delta that satisfies, so we have epsilon equal to 1. What is the largest delta? So you have x minus y, or x minus 5 is less than delta, implies that x squared plus 15x plus 50 minus 150, so it's that minus 100 is less than 1. So that means that x squared plus 15x is less than 101. Or I should subtract the all over, so it's minus 101 is less than 0. And then you could also do the negative of that is less than 0 because it's an absolute value. 101 is prime, so you can't really factor that well. So x is, okay, what is negative b plus or minus the square root of b squared? Oh my god. 15 squared is 9 times 25 is 225. So 225, it doesn't work. So you have to do the negative. Negative plus. So that'd be 15 plus or minus 225. Ah! It started playing. Plus 404 over 2. Oh man, I love this. Negative 2. Can I use a calculator to find the largest? Oh, that's a minus 15x. That doesn't change anything. except that. So x is equal to 15 over 2 plus or minus. Square root. Minus, yeah, I see now. 225 plus 404. Divide by 2. 12.5399. Alright, 15 over 2 plus. So x is around 20.0399. And alternatively, 15 over 2 minus the value is going to be negative 5.0399. Alright, and then you do x minus 5, so 5 plus 5.0399. So I'd say the answer is delta is approximately equal to 10.0399. That is the largest delta you can do. Change the... I did! Change... Oh, it changes... It goes to 0, doesn't it? Oh yeah, that does... that changes a little bit. Changes it a tiny little bit. Yeah, goes to 0. That's pretty epic. It's plus 50. It's minus 49. The answer is going to be completely different. Oh, wow. 49. Great. Great number to have there. Square root of b squared 225 plus 4 times 49 over negative 2. X is approximately equal to 15 over 2 plus square root 225 plus 4 times 49 over 2. It's bang, bang. Alright, so we get 17.759 negative 2.759 means that delta should be less than 7.759. Am I good? Did I get the answer? Between. So I'll just do that. Check my quadratic equation. What's A? What do you mean, what's A? -1. Ah! Huh. Not my strongest day. Delta is less than 0.2. No. 0.103? Wait, I have to plug this into my calculator. 193. There we go. What's a Bessel function? Is that the right answer, though? Did I finally get it? Second one is less numbers. Yeah. That's what I'm talking about. I can't read it. It is a well-known fact. Yeah, just write it in the, Yes, Jimzor CS, please. Please. Get it. I can't see the picture because of the red. You, like, scribbled out half of it in red. I can't read it. Is it just by itself? I can't tell. What's on the bottom? Is it an n? Sum of 3 to the n over combinatoric. Okay, thank you. Sum n equals 1? Yeah, that's got to be a 1. To infinity, 3 to the n over 2n. N, knowing the fact that n equals 1 to infinity of x to the n over n times 2n, choose n, that's a lot of n, is equal to, this is a weird one, 2 rad x over 4 minus x arctan rad x over 4 minus x. Okay, so how do I relate the fact that that doesn't have an n in the denominator to this other one? Alright, let me try to think of what 2n choose n is. Oh, I forgot the definition. It's related to, okay, let's do 2 choose 1. It's 2. 4 choose 2. It's related to Pascal's triangle. 1, 1, 1, 1, 0, 1, 1, 0. Who cares? 1, 3, 3, 1, 1, 4, 6, 4, 1. 0, 1, 2, 3, 4. Right there. 4. Choose 2. 0, 1, 2, 6. Okay, how is that related? Okay, 4 times 3 over 2 times 1. That's how you do it. Alright, so you have 2n all the way up, down to n plus 1. Is it always n plus 1? Whatever the lowest. N plus 1 or n, depending on whether n is even or not. No, it's 2. It's to n plus 1. And then on the bottom, you have n factorial. So, but you can't do it in 5. Alright. So if I have an extra n on the bottom, basically, that'd be slooping that out of there. So that you'd really have... So this is the same as 2 times the sum from n equals 1 to infinity, x to the n, over 2n minus 1, choose n. So that would be related-ish. So now the issue is that I don't have the luxury of doing that. So if I were to put a minus 1 up here, I'd have to put a 2n up here. Studying topology for my exam. I very much prefer topology questions. Yeah. Alright. All the way up until n plus 1. Yeah, that works. Alright, I think I got it right. Alright. It probably uses properties of the choose functions. Alright. Somehow, need to either make it... Oh, shoot! Oh my god, that would make it easier. It's 2n minus 2. That would work with that. Alright, if I did 2n minus 2 there. No, it wouldn't. I'm an idiot. God. That'd be 2n minus 1. So, you need to remove the user slash from your Patreon link. Thank you for telling me, Daniel. I appreciate it. This is the... Oh! Wait a minute. Did I do it right? Not even close. Why would they... That's so weird. Oh my god. Wow. Alright. Yeah. I would not have done that. Ever. They use, like, the what is it? The Weierstrass substitutions. It's crazy. Is that not what they did? That's that. Why would they do that? Alright, you're giving me the... Alright. I'm gonna look at it. I'm gonna see where this is in the thing. And I'm gonna see how to do it, because I have no clue what I'm doing. Oh no. What do you mean, oh no? S equals solutions. It takes time. Don't look. Don't look? Alright. Takes time, doesn't it? Oh, wait a minute. No. Alrighty then. I was thinking doing the integral, but that makes absolutely no sense. That denominator. Just shove it in your head like von Neumann. Yeah, that is a good idea. Von Neumann, I'm sorry. Why smart people have less subscribers. Do you know Kim Kardashian? Yes, I know Kim Kardashian. For hours, yeah. I never take any breaks. You'll realize it's so obvious. Is it now? Is it really that obvious? I don't know. I'm not a scientist. Alright. If two n choose n, it's gotta be like something stupid. You'll realize it's so obvious. It's so obvious. Okay. Oh. Oh no. I'm stuck. It's a lot easier to do these when you're not under pressure. You have all the time in the world to just look through it. So it's kind of it's not happy times right now. It's not happy times. 29. Yeah, I got it copied down, right? Okay, so there's another formula for it. So 3 to the n over, what is it? How does it go? It's 2n factorial over n factorial times n factorial again. I think that's how it goes. Right. Let's do 4. So you do 2 times 4 factorial over 4 factorial times 4 factorial is equal to I don't know. Why didn't I think that'd work? Yeah, that seems right. Where's my eraser? Okay, sum from n equals 1 to infinity, 3n, n factorial squared over 2n factorial. Yeah, alright. So then right here, this is the sum from n equals 1 to infinity, x to the n minus 1 factorial times n factorial over 2n factorial. I have no clue how this is obvious. This problem solving. Wait. Hold the phone. If no. Alright. Oh, wait a minute. If only that was like an n plus 1 factorial, that would maybe help. But other than that, I can't think of anything to do with this. Tell us a wedge product. He doesn't even know what a wedge product is. This is interesting. This is a really fun problem. This is a good one. Yeah, this is a great time. Having a great time. Alright. The only thing I can think of is like an integral, but like that doesn't make any sense. Unless it does and I'm dumb, but I'm not doing it. Wait! It's an integral! I was right! It's a derivative! I was right the entire time, and I was doubting myself, because for some reason, I'm like, hey, isn't it a good idea to integrate in respect to n? Like a big idiot? Alright. I was throwing around that idea, and I kept saying, no. God have mercy on my soul. What's the stupid freaking... Yeah, this is just straightforward-ish problem from then on. Alright, gotta figure out the derivative of that. It's not fun. Alright, 2. Alright, 1 over 2 times goes away. Square root x over 4 minus x. Derivative of that is 4 minus x minus x. It's 4 on the top, isn't it? No, it's not. X over 4 minus x. Take the derivative of it. 4 minus x minus x. So I take the derivative, it's -1 times x. Then over 4 minus x squared. It's x squared. There we go. Schloop. Multiply that by arctan of the same thing. This is just a lot of work. Plus 2 rad x over 4 minus x. Arctan goes to 1 over 1 plus the thing squared. Then on the top it's 4. And then times 4 minus x squared. Right there. And so if I just multiply it by x on both sides, I'd have the thing. So if I plug in 3 into there, I'd have to get 3 times 4 over rad 3. Right there's 1. 4 over rad 3. Arctan of rad 3 over 1. Arctan rad 3 is pi over something. Rad 3 would be sine of x over cosine of x. Sine of x has to be the rad 3 over 2. It's bigger. It's pi over 3. So that's pi over 3 right there. Then plus 2 times rad 3. It's 1 plus 3. It's 4. 4 cancels out. That's a 1. That's a 1. It's that. that's the answer. So rad, the 3 there cancels out with that. 3. 4 pi over rad 3 plus 6 rad 3. Ugh! Sem! Sem! Oh my god, it's Sem! Oh my god. Is that the answer though? I might have done like the derivative wrong because it's a stupidly long derivative. So I get the idea. Let's move on. Let's move on. If that's not the answer, screw me. That problem's not being solved. You know for a fact. I'm just kidding. Yeah, founder of the icon. Yes, Sem. Welcome back. Okay, that's not very nice today on the games. Alright, if this line of reasoning wasn't good along the way... Hello, math. Can you do the number theory problem by looking at it mod 3? I don't think so, because the problems that I looked at, none of them were mod 3. None of them were. So, like, they were all, like, multiples of 7 for their least prime. Go ahead and do a different... Go ahead and suggest problems. Okay, let A, B, C be positive real numbers such that A, B, C equals 1. Prove that A minus 1 plus 1 over B over... or times... Oh, that's a big inequality. It takes a lot of big boy math. Matthew. If A, B, C equals 1, what is the minimal value of A plus B, A times plus C, A, B plus C? I've done that problem before. Okay, let A, K be the remainder that a number K to the P, K to the P gives when divided by P squared, where P is a prime. Find the sum from one. Let A, K be the remainder. That number K, P gives when. It's not that long solution. I don't know. Oh! Alright. So it's the sum. Yeah, I'm not doing that one. That one's complicated. Let's go ahead and do the maths MOOC's alpha, his question. So you have A minus 1 plus 1 over B times B minus 1 plus 1 over C, C minus 1 plus 1 over C, no, plus 1 over A. So it's like it's translated to the left one. Alright. So first of all, what I notice is that we're going to have an ABC when we multiply it out, and a 1 over ABC. So now ABC is 1. This would also be 1. So this is going to be 2, and then a bunch of other stuff. And it also in the product, we're going to have 3 minus 1s. So that goes back down to a 1. Alright, let's do the product. Alright, A, B, minus A, minus B, plus 1, plus A over C, minus 1 over C, plus 1 over BC. Alright, this is going to take a while. Alright. Is equal to ABC minus AB plus B minus AC plus A minus 1 minus BC plus B minus B over A plus C minus 1 plus 1 over A I sent it on Discord. That's an interesting problem, but you know, I'm sort of obligated to do this one now. Plus 1 over C. Why did I do that one first? Plus A minus A over C plus 1 over C minus 1 plus 1 over C minus 1 over CA plus 1 over B minus 1 over BC plus 1 over ABC. So that goes to 1. That goes to 1. Plus 1 minus 1 plus 1 minus 1. So we don't have to worry about any of those. There's a stray minus 1 in there, which I don't know how to deal with. Alright. Let's go ahead and get all the A terms together. So we have A times, so that's minus B minus C plus 1 plus another 1 plus 2. Then minus 1 over C. Yeah, that's that one. Let's get all the B terms together. So 1 minus C. It's another 1. Minus C. There's no A term. There's no other. It's a minus 1 over A. Alright. C terms. I see a 1 there. I see a minus A. That looks to be... So there should be a C. What did I do? Okay, I got rid of that term. So minus A minus B. There should be a minus B somewhere in here. There it is. Plus 1. That goes to an A. That goes to a minus 1. That goes away. So those are the terms I care about. Alright. 1 over A term. 1 over A. Those are all gone. There's a minus B. There's a plus 1. Minus 1 over AC. Plus 1 over BC. This isn't helping. This is not. I don't know about this one. Okay. Yeah. I don't know. So 1 over B has a 1 term and then a 1 minus C term. It's 1 over C. Yeah, there's probably an easier way to do that. This is definitely try so. Okay, ABC is equal to 1. So A is 1 over BC. So I have 1 over BC minus 1 plus 1 over B. B minus 1 plus 1 over C. Times C minus 1 plus BC. So if I do a C there, that's going to be a C plus 1 over BC, then a minus 1. If I really wanted to do that one, I'd get a BC plus 1 over C. No. Yes. BC plus 1 over a BC. So that'd be a minus BC on the top. That'd be a minus BC on the top, which makes this just a 1 over BC. Oh. Alright, that one, it can't be simplified, but if I wanted to make it over BC, it'd be BC squared minus BC. Yeah, no, this one just, I can leave, I think. C minus 1 plus BC. Alright. That one, if I multiply it in, I get C plus 1 minus BC over BC squared. That'd just be over C. So that'd actually be, no, that's wrong. So it's over C. So that's BC minus C plus 1. BC minus C plus 1. So that's interesting. So that's really cool, the way that turned out. So we're going to have BC squared, alright, when we multiply those two together. And right here I have minus C, so let me write this way. C minus BC plus 1. Right here we have minus C plus BC plus 1. So those are heavily related. Minus C squared plus BC squared plus BC squared again plus B squared C squared. Alright, let's go through it term by term. Minus C plus C minus plus BC squared minus B squared C squared minus minus BC overall, and then minus C plus BC, bang, 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 plus 1 out the other end. Alright. Plus 1. So that's 2BC squared. What was it? Minus B squared C squared. And plus 1. Just try making a smart substitution. Oh, thanks. Alright. It's interesting. So when I do that, it's in terms of just B's and C's. It's a smart substitution here. So if I do like U is equal to BC, what would that give me? Right, so that's 1 over U minus 1 plus 1 over C U. Or C over U. Okay, let's do 1 over BC there. Okay, so U minus 1 U minus 1 plus 1 over C U, or C times U. Right there, I do C over U, or 1 over, so 1 over CU minus 1 plus BU, 1 over BU minus 1. There's a lot of minus 1s. So I don't know how would I do that? Introduce variable x, y, and z. So x, y, and z. Okay. So I don't know. That wouldn't help. How about I just get rid of the -1? How'd that help? That would be AB plus 1 over B. Y is... Let's see how that would help. Introduce... So 3 variables substitution. To make this whole thing easier. But I don't think it would help to make it just an easy substitution. And those aren't very easy to work with in of themselves. So maybe, alright, A minus B plus 1 over B times AB minus B, BC minus C plus 1 over C times AC, or CA minus A plus 1 over A. So I guess what I could do is do... So X is AB minus B plus 1. Y is BC minus C plus 1. No, that wouldn't help still. So the bottom goes to 1, which is what I saw. AB minus B plus 1. BC minus C plus 1. AC minus A plus 1. So X equals 1. Y equals 1 over A. Z is 1 over A, B, C. Alright. Let's try that out. So that's 1 over Y minus X plus B is A over C, B over C, Z. So wait a minute, what if instead I did Y equals A, Z equals AB? I feel like in the form I have it right now, that would maybe help a little more. Z minus, now to get from Y to B, I have to do Z minus is 1 over BC. Okay, BC. B is 1 over AC, so it's 1 over CY plus X okay, BC, that is close to being Z if instead of an A we got a better feeling about a substitution like that. I don't know why. That doesn't make sense. I don't know what I'm doing. Alright, if I go back to the original with your substitution, alright, I'm going to give you the benefit of the doubt. 1 over y minus x plus 1 over b is a times z. But a is 1 over y, so it's z over y. Alright, times b minus 1. So b, yeah, it's still really hard to represent. It's z over y. I just talked about that. It's z over y, be 1 over b, so y over z would be b minus x plus 1 over c. How do I get c? It's just 1 over z. And then 1 over z minus x plus y. Alright. How does this help? And multiply everything by x, y, z. Alright. xz minus x squared yz plus xz. 2 xz's. Wait a minute. xyz xz squared. Alright. Y. xy squared oz minus x squared yz plus xy. Then xy minus x squared yz plus xy squared z. Still don't see how this is to the original equality. So plug it into here. Basically it says 1 over z, which is AB, times c, which is just z. Oh, z is just c. So right there is just z. Z right there. So xyz squared, xyz squared. Why does this help? What? It's 1 over y to create 1 over y squared is a. Sorry, 1 over z is ab. Yeah, no. You could use Lagrange Multiplier. Try plugging... What? Lagrange Multiplier? What? Oh my god, I've been spending so long on this. Alright. How does this substitution help at all? And that multiplication... Oh! Whew! You said it's not a long solution. Do my problem. Perhaps. Introduce x equals 1, y equals 1 over a. c equals 1 over ab. How would you do that? Alright. What's so special about this one? What do I do? You can factor out an x from like everything. And the x just goes away because it's a 1. Why would you substitute something in for 1? Z minus yz plus z squared times y squared minus yz plus yz squared. Yz squared plus yz plus y squared z. Wow, that's so cool. What? How did you think? Math MOOCS. I appreciate the attempt at the help, but like, I have no clue what you want me to do with this. Every question I get is just oddly specific. Ugh. Sorry, so we have ABC is 1. A plus B. A plus C. B plus C, is it? Oh no, I forgot. Oh, on Discord. Woo! Alright. Sharian has a new lollipop and wants to know how many licks it takes to get to the center of it. He knows that the quantity has the same value. Given that the fractional number of licks are allowed, how many licks are necessary to get to the center of his new invention? That doesn't make any sense. What? That doesn't make any sense. Alright. So we have the limit. So x goes to infinity. X to the x times 1 plus 1 over x to the x minus e plus e over 2x. Now my instinct would say, right there is e. So then e minus e is 0. Right there is also 0. 0 times infinity. Oopsies. Oh. So I could do a 0 over 0 case and do L'Hopital's rule. That's what I'm thinking. What's the derivative of x to the x? That wouldn't help really, would it? Alright. So x to the x obviously grows extremely large. How does that converge? No, it's x squared. I'm blind. Yeah, that would make it easier. Alright. Yeah, I'd do L'Hopital's rule on this one. Would I? No, I wouldn't. Ugh. It's great copy pasta, yeah. Alright. Yeah, I think that usually you do L'Hopital's rule with that. So I'll go ahead and attempt L'Hopital's rule. not the most efficient way to do the problem. Definitely not. But it's fun. It's a fun little derivative thing. Woo! Derivative of that. X times 1 over 1 plus 1 over x. Multiply the top by derivative of that. It's negative 1 over x squared. It's negative 1 over x. This is a negative. Then a 1 over x plus 1 there. Alright. So now one goes to e negative e over 2x squared. So on the top, we have this monstrosity to the x. Yeah, so I guess you're saying that it's a really hard problem, and you said it was easy, and now you think you're funny because you just wasted my time. All that stuff. I could probably multiply that through by an x and be fine. X squared. Why did I take the derivative of that? That doesn't make any sense. Why would I do that? Yeah, L'Hopital's rule is not the way to go, my friends. Not the way to go. It's just evaluating the limit. I'm having trouble figuring out what to do. What to do, what to do. So this is a really awful thing to integrate. Never integrate that ever again. I mean, differentiate. Just plugging it in. It's really annoying. Okay, how did you get your answer? Why doesn't it diverge? Plug in infinity. You get infinity here. You get e there. Minus e, you get plus 0. That's infinity times 0. It's indeterminate. You don't know. So now the question is, how do you even do it? What are you doing? Because, like, everything, if I multiply them individually, everything is going to go to infinity. But for some reason it somehow converges to 11 over 24e. He did the same thing where you like split it up. How do you do that? What do you do with that? Ugh. So apparently he also did this. But what on earth am I supposed to do with that? I don't know. Multiply the top and bottom by x? That wouldn't help. Wait. At Phomonica it's stupid. Yeah. You're supposed to do L'Hopital's rule? No, I'm not. It just takes forever. Do it in 5 minutes. Oh my god. I'm going insane. Ugh. C-Day Animu Games is that... From a competition, yeah. How do you do it? Oh! This is sad. This is the real test of man. Is whether or not I'm going to go insane. Oh my god. Oh my god. Yeah, how this limit is formed, it becomes apparent that we are looking to find... Does it become apparent? It's negative a half. Oh my god. That is so dumb. That is so stupid. Oh my god. What the heck is that problem? That is such a stupid problem. Oh my god. That is so... Oh my god. No, I'm not in university. Those are just really hard calculus problems, and you're supposed to do, like, very... This is why I'll never do number theory. It's because of stupid stuff like that. Ugh. It's natural log of a negative I. That I can do. Oh my god. Natural log. Negative I. So the way you do it... I'm going insane. No, I'm not. Alright, so the way you do it, you do the real part. It's the natural log of the magnitude of the complex number. And the second part is I times the argument of the complex number. And the argument is just the angle. So negative I relative to there has an angle of 3 pi over 2. It's a distance 1 away from it, so this is natural log of 1 plus I times 3 pi over 2, and you can actually add 2 pi n to that for any integer n, for n element of integers, which is then just I times 3 pi over 2 plus 2 pi n. So those are all the values for it. Really, you could say that the principal log, this is the principal log of negative I is just 3 pi I over 2. Monica should prove that there exists an ordered field R with least upper bound property that contains Q as a subfield. Okay, you want me to prove it? I'll show you that I know my gosh darn real analysis. Alright, so we'll do the decadent cut. Wow, this is pretty cool. So, for... shoot. Dang it. I used to have it memorized. Alright, so decadent cut. So basically, you cut it at some point along the rationals. So it is a pair of sets, which we'll call A and A prime, such that it has the following properties. So A is going to be called the lower, A prime is going to be called the upper. So for A, if X is an element of A, that means if X is less than Y for some Y an element of A, that implies that X is an element of A. Alright, number 2 is that if X is bigger than Y for some Y an element of A prime, that means that X is an element of A prime. So basically they're closed upwards, and that 3A union A prime is the rational numbers. Yeah. Okay. So this is the decadent cut definition. So I think I got all of it. So it's closed up. There's nothing else, is there? I don't think there is. Alright, and both of these are subsets of the rationals, and they have that property. So we're constructing it from the rationals. Where did I put my... okay. Decadent cut. That's epic. So now we say a pair A prime A, or A prime, is less than B prime if so A needs to contain B. So this is A. So I want it. So A is a subset of B, and we need B prime to be a subset of A prime. That's a less than or equal to. So that's how you define that. How do I know that it's transitive? Because transitivity of the subsets. Alright. you can define addition on these. So you do A prime plus B prime is going to be, alright, set of A plus A prime, so set of A plus B for A and A, B, and B. So for the lower bound, I can just do shloop. This is A, this is B. When I add them together, the maximum value it's going to achieve is going to be at whatever point this represents plus each other. Alright, and then if I call this A plus B, then the other one's going to be Q minus A plus B, which is actually harder to define, so that's why I'm not doing it. Actually, no, I could also just do the same thing for this one. So it's going to be A prime plus B prime for A prime and A prime, B prime and B prime. Alright, so that's how you do it. Okay. So then the way we multiply these is more complicated, which is why we have the two of them. So if their values so this is their maximum values, and here's 0. So let's say they're both positive. Their multiplication has to be positive, but I can't just multiply arbitrary elements in each of the sets, because if I multiply two of these, because it goes arbitrarily far back, it'll loop back to the front. And so what you do is you look at the second set. So you look at the sets going up. So you have multiple cases. So if we have it that A prime is bigger than 0, so that means every element is bigger than 0, and B prime is bigger than 0, so that means that every element's bigger than 0. So if both of these are positive, the way we define it is you do the rationals minus A prime times B prime, and then you do the set of A prime times B prime for A prime and A prime, B prime and B prime. Alright, and then you just do the opposite of it. Alright, now if A prime is less than 0, also, I forgot about this, is that their intersection is empty. No, so that's not required. Is that A is less than or equal to A prime. So that means that for every A in A, there exists an A prime, an element. For every A prime and A prime, A is less than A prime. So that's what that means. Alright. So that's actually required for this next part. If A prime is less than 0, B prime is bigger than 0, then we have to pull a sly move. So you'll have something like this. So 0. So you need it to become negative. So you need it to sloop on down there. So this is A, this is B. Then this is A times B. How do I make it go all the way down there? So if I do the lower set on this one, so that's a negative value, and I do the lower set on this one, that wouldn't work. But if I did the bigger set on this one, what would happen? So all of those are negative, so that those would all become negative. These would all become further and further negative, so that would be the lower end of it. And then the other one, okay, yeah. So you do the set of A times B prime for A in A, B prime in B, and then you do rationals, removing that. You get the idea for that. And then same idea for the other one, and then when they're both negative, you just do the both of the downward ones. So you can continue with that definition. So those are all, that's multiplication, and then you can prove it's distributive pretty easily because it just relies on addition and multiplication of each of the individual sets. And so how do I prove that this is actually an ordered field and that they have inverses? So we could do 1 over A would be this set. So the pair where you do 1 over A for A in A, and then you do the set of 1 for A in A not 0. And then same thing with A prime. So you just do that. I think that works. Pretty sure, because if you multiply it, yeah, that would be order. That would actually flip. So flip these. Yeah. So that would be the, because it flips the order. So you gotta flip those. Yeah, alright. I think that's how that works. If I'm wrong, correct me. So it has inverses. Those are obviously inverses. And they go to 1. So 1 is where you do the set of A less than 1, or rationals less than 1. And then for the other one, you do the set where rationals are bigger than 1. And now you actually need to do equivalence classes on these, because I could have also, no. So they're complements of each other. Yeah, so you gotta do that. Let me go ahead and see. Dedekind cuts. I'm gonna make sure I'm doing this right. I don't remember exactly, but I'll prove that it works. Definition. Okay. Partition of the subsets into 2 subsets A and B. Close downwards. If X is an element of A, then there's a Y an element of A. So, oh, it does not contain a greatest element. That would do it. Yeah. So it does not contain a greatest element. I forgot to include that. So that makes it unique. Alright. Wait, let me see if I got my definition of multiplication right. I don't see anything for multiplication. Add. Additional. Alright. Okay, let's go on to a PDF. Double check. Main definition. Okay. Arithmetic. Okay, where is multiplication? Where do they define multiplication? A3. Oh! Oh, that would be much simpler. Yeah. General multiplication. Oh, I was right. You need to do stupid stuff. If A1, B1 is negative, yeah, alright. So that's an alternative definition. I just looked at it. This is right. So we're good. So we don't need that anymore. So now for any rational number, we can create a representative of it in the Dedekind cut world, which I'll represent by a Q with little brackets around it. And it's going to be set where Q is less than 1, is where the rational number R is less than Q, and then the set where the rational number R is bigger than or equal to Q, and that'd be the Dedekind cut for every rational number Q. So it is an embedded whatever. You can prove that it's a ring. I'm lazy, I won't do it. You can prove that it's a field, sorry. Where that is the inverse. Wait, let me see. Least upper bound property. Okay, let's prove the least upper bound property. So, if we have a set A, which is a collection of these Dedekind cuts, then the supremum of that cut is just the union. So it is the union for A prime in that set A of A, and then the union for A prime, an element of A prime. That will be the supremum, because everything will be a subset of it. And how do I know that it's finite? because it's an intersection here, sorry. Alright, you can prove that that's the supremum really easily, and you can prove that it is, finite, because it is actually less than or equal to the upper bound by properties that you can very easily verify. So it's that. That's it. Proved it. Monica, how about the equation p squared minus p plus 1 equals m cubed for... Oh my god. Monica, how about prove the... I don't know what that means. Okay. P squared minus p plus 1, and it's a perfect cube. Oh, number theory. I can't deal with these number theory questions, I'm gonna be honest. They're just explaining Dedekind cuts to all of you. Now that is a order field, Q is a subfield, whatever. Do mine, what is yours? What is yours? I don't know, I'm scrolling up really far. Prove inverse function theorem. No, that wasn't even a hard one. I just needed to make sure. I am posting it. You can't see it? I can't see links. Wait a minute. Switch account. There we go. Now I can see it. Show. There we go. Okay, f from r to r is differentiable. F of 0 equals 0. Absolute value of f prime of x is less than or equal to f of x for all x in R. Prove that f of x equals 0 for all x in R. So you have it that absolute value f prime of x is less than or equal to f of x for every single value of x. We have f from R to R. So that's interesting. So that puts a pretty strict bound on how fast it can be increasing. So f of x needs to be really small for that to work for every single value. Okay. It's interesting. So I'm thinking about it, and it's got to do with the fact of the negative infinity to infinity, because I can think of an example where this isn't an issue, namely 1 over x and natural log of x. It's the one I immediately thought of for some reason. But 1 over x gets really close to 0. That's the derivative. That's much slower than natural log of x. So you could make this a question about the interval from 0 to 1, where you the interval, open interval from 0 to 1. So you can't have the boundaries. The boundaries are the important part, because if you had bounds, you'd instantly be able to do it, even if you just had a single bound. So, and I also have f of x is 0 for one of them. But because it's just dealing with f prime of x, really, e to the x plus 100. Yeah, but its value at 0 has to be 0. So f of x is 0. Are you good in numerical mathematics? Nope, I think we've learned that today. Alright. So why is it impossible for it unless it's constant? So obviously the f of 0 is 0. That this implies f of x is 0 for all values. So e to the x plus 100 would be an example if we didn't have that condition. Because its derivative is just e to the x, which is objectively less than it. It's just in order to get it to go to 0, it would need to hit a negative. It's the okay. This is really hard. Is it also f prime of x? So f from r to r, differential f of 0. Yeah. Wow. All right. So what if it's 0 up until it reaches 0, and then it's smooth? It has to be first differentiable everywhere. So if it wasn't differentiable at 0, you could switch it to be the natural log. So that you'd have 0 for the derivative as well. And bang, you started off a little bit higher though. And so there's tiny leeway that you have to get around. So if I have a constant function like that, it has to intersect a constant derivative, derivative right there, past this little section right here disobeys it. That's really difficult. Yeah. So this is putting a bound on the derivative. If I had something like that, so it's always positive, I can just assume that it's always positive. Alright. Are you sure that's true? That seems fake. Yeah. That's weird. I'm not approaching this the right way. Can you give me a hint about if this is a topological proof. Wait a minute. Wait. So that means that the derivative at... shut up. Don't give me a hint. The derivative at 0 is less than or equal to f of 0, which is 0. So that it's less than or equal to, it's an absolute value, which means that f prime of 0 is 0, meaning it is a minimum, maximum, or inflection point at 0. And so now all I have to do is prove that I can pick an interval around it, like an epsilon ball. Alright, and I'll prove that it has to be 0 elsewhere in that epsilon ball. Alright, so now I have to figure out how to just be able to inch it a tiny bit away. So if I inch it a tiny bit away, that right there is f of epsilon over epsilon. It's approximately going to be f of epsilon over epsilon, which somehow has to be less than or equal to f of epsilon. So if I take epsilon sufficiently small, so the thing is that if f prime of epsilon is bigger than 0, then I'd have schloop. If that's the approximation, that right there is the curve. The actual tangent is going to be very close to 0. Basically, I want to show that f prime of epsilon is less than or equal to f of epsilon over epsilon for a sufficiently small one, or that it has to be. So if epsilon is less than 1, the second inequality is not true. Is not true ever, because you have f of epsilon, divide by f of epsilon on both sides, you get epsilon, 1 over epsilon is less than or equal to 1, or epsilon is bigger than or equal to 0, or 1, epsilon is bigger than or equal to 1, which is epsilon's less than 1, the second equality is never true, and epsilon's bigger than 0. So I just have to figure out how to formalize this bit right here. So I gotta show this. So this has to do with the second derivative, I think. So for the second derivative, if it's concave up, that's not the case. But if it's concave down, it couldn't be concave down. It has to start at 0, then either go up, or concave down would be like this, where the absolute value-wise, it still wouldn't be true. So yeah, that's the wrong... Yeah, I'm still streaming. Consider the function, take the derivative, prove it's decreasing. one solution. Consider e to the negative 2x times f of x and take the derivative. E to the negative 2x times f of x, take the derivative. It becomes negative 2 e to the negative 2x f of x plus e to the negative 2x f of f prime of x. Plug in 0 there. What would that do? F squared. Alright, so that's not f prime, it's 2 f of x, f prime of x. Alright, so I can factor out a 2e to the negative 2x f of x, and then I just get an f prime of x minus 1. Alright, if I plug in 0, I'd get 0, obviously. Prove that this is decreasing. So f prime of x is always less than or equal to f of x. Now what would that actually tell me about it, though? Oof. That function's always decreasing. What? Can't see anything on the board. Bad way. So right now, I have 2e to the minus 2x f of x times f prime of x minus 1. Alright, now what do I do from here? Because that doesn't seem like indicative of anything. Couldn't hear anything. Hello! Put f of x back in. Only factor 2e to the... That makes sense. F of x times that minus f of x. So that is less than or equal to 2e to the negative 2x times f of x squared minus f of x. Right? Unless it's negative, then right there would be a plus or minus. F of x times f prime of x is less than or equal to absolute value of both, which then, yeah, so absolute value of f of x squared is just f of x squared. Alright, I get your idea. Then and also write f of x squared as absolute value. Why would I do that? Okay. And then factor, I can't because that's not an absolute value. It wouldn't be a less than or equal to. It would be, it could be greater than. Yeah, but... So this factor would be less than 0, but that's always bigger than 0, so it's decreasing. Minus f squared. Yeah! That is true. So that, oh. So that is also absolute. Okay. That's just 0. Yeah. Oh. Alright. Okay, so that's just 0. But that's less than or equal to 0. That's always bigger than or equal to 0, which means that this part is less than or equal to that part. What? I don't even know what a Bonic space is. Go on now. Okay, wait. So f prime of x there. How do you do that? Yeah, so you get that this is less than or equal to 0. Alright, so you get that this is decreasing everywhere. But this little section is always bigger than or equal to 0. So that means that I can do f of x times f prime of x minus f squared of x is less than or equal to 0. Is that not what your f squared of x is equal to 0? Absolute value. Alright, so you get 2e to the negative 2x, absolute value of f of x, absolute value of f prime of x minus absolute value of f of x. Alright, so then what am I doing? You can post a link. Post a link if you have a link that shows this. It's like I have no clue. Screenshot by light shot. G prime of x. 2f of x. So g is decreasing. Oh! Why did you... Okay, I didn't know what you meant. I was saying the right thing the entire time. Yeah, it's decreasing. Alright. So it's decreasing. Why would it be less than or equal to 1? Okay, wait a minute. Okay. Why is it less than or equal to the absolute value? Because one's less than or equal to the other. If they're both negative, then when they multiply, they become positive. It's if one's negative, but one could be positive and the other be negative. So I don't get how they do the inequality there. Yeah, I don't get how that inequality works. Less than or equal to 0. And then f squared of x is 0. And it's decrease. If it's bigger than or equal to 0 for all values, it's true. I see how this proof works for bigger than or equal to 0. But I don't see otherwise. What? What? How does that at all imply that? What? Okay, so two things I don't get. Why is f prime of x times f of x less than or equal to absolute value of f prime of x, f of x? And then second thing I don't understand is the step where e to the negative 2x times f squared of x being decreasing and having f squared of x equals 0, f squared of 0 equals 0. I don't understand how that implies f squared of x is 0 for all x. I'd solve your third grade algebra problem. Prove 0x equals x. Wow, that's a good one. 0 plus 0 times x is 0x plus 0. X is also equal to, because 0 plus 0, then is 0x. 0x equals 0x plus 0x. Subtract 0x on both sides, you get 0x equals 0. It is a property of absolute values. Okay, so if f prime of x is negative 2, because that, oh my god, I'm an idiot. Yeah, okay, I get that now. But what's going on here? So that part I get. Yeah, I was being dumb. So what is this step? Oh, what about it means I just don't get that part. Just think about it again. Is decreasing in R. That's a decreasing function. Square root of 0 is 0. It starts off at 0. It's decreasing. So, oh my god, I'm dumb. Yeah, no, I get it now. Oh, that's a clever proof. Yeah. Yeah, no clue how I was supposed to do that without knowing it beforehand. Yeah. It's a nice problem, yeah. But I mean... yeah. So I think I might end the Ask Me Maths. Just the problems. Problems are usually very specific and hard, and I have to think about them a lot. So I don't know if I want to keep doing these. Because it usually takes math problems a lot of time to think them through. Come up with clever solutions. Okay, I have an easy one. For real y and integer n greater than 0, for every real y there exists a real x equals y to the n. What? Okay. Then, what? Obviously. Oh my god. Oh my god, proof by induction. N equals 0. I mean, n equals 1. Y to the 1 is y. N plus 1 case. Y to the n plus 1 is y times y to the n. Y to the n exists. Y times something exists. Someone's asking me to find the value of x for which... Ooh, okay. E to the x is negative x. Which value of x? So obviously x is less than 0. The way to find it's probably related to the Lambert W function, but I don't remember how to do it at all. So it's the inverse of x, e to the x. So f of x is there. W of x is f inverse of x. Alright. Then how do I solve it? Well, first I have to get it in the form of x e to the x. So that's e to the x equals negative e to the natural log of x. If I divide by it, I'm both sides. That wouldn't work. there's a gosh darn way to do it. I don't know what it is. Something dumb. Oh, wait. Raise both sides to the power of 1 over natural log of x. Then multiply by x over natural log of x again on both sides. That wouldn't help. That was the trick I used in the other video. So, yeah, I don't know how to do it. If x is less than y, there exists a p in the rational number set such that x is less than p is less than y. Uncountable chain of power set of n. Oh! That's a good problem. Ah, wow. Yeah, uncountable. That's crazy, yeah. I don't know how to do that. Uncountable chain. Oh my god, I'm just gonna lay on the floor. I know what a chain is. That seems like it shouldn't exist. An uncountable chain? Oh. I'm thinking. Just making it uncountable. It's giving me anxiety. It's really easy to This one took me a while. Oh my god. You guys really... Okay. Uncountable chain. So... Okay. Uncountable chain? Are you... Okay, I'm looking it up because I'm tired and I don't want to do it. some finite chains, some infinite countable chains. Okay, first let's recall that the set of rational numbers is countable. Alright. Oh. Alright, yeah, that's not that hard. Alright. So you have phi, which takes you from the real numbers to the power set on the irrational numbers. What you do is you send number x to the set of values less than or equal to x. Alright, then you can do embedding or a bijection between the power set on Q and the power set on the natural numbers. And then you actually you do phi to psi of phi x. For every x, this is going to work. It's going to be a subset psi phi of x. Really, this could be the embedding from, or the bijection from Q to N, and that just be the image of the subset. So that's the image of the subset there. That makes sense for why it would be comparable, because each of those are comparable. This is a bijection, so it works. Also, find a function from 0, 1 to itself whose graph is dense in 0, 1. No, thank you. You know what? I'll give you what you want. Okay, how do I... From here to here, it goes... It's a function. How do I do that? How do I diddly darn? I sent Discord problem solution. Oh, thank you. I love my dad. Shirt is quite slick. Yeah, I know, it's a great shirt. Hint, Dedekind cuts. Yeah, alright. Also fun. Find a function whose graph is dense. How do you... Oh yeah, that's a great sound. That's great. Okay, I just read a solution to it. Your need rest. Alright. So, the way you can do it is stupid and an analysis problem. Alright. So what you do is you construct the set. I'll call it, you construct a value called an, which is the square root of the nth prime so p is a prime, and then you define a set Qn to be the set of x in the interval such that x minus an is an element of the rationals. So if it is the subtraction of some value which is the square root of prime, then it's in the rational, so it's a rational number plus one of these, and it's in this one. Alright, and then you define the function, and this is also dense in the thing. It's just they're shifted over by the square roots of primes. And the reason why we need to have that is because the square root of two different primes is irrational for n not equal to m. Because their subtraction is an irrational, each of these qn disjoint and dense. So then you define f of x to be qn if x is an element of the big set qn, and 0 if not in any. There. And qn, sorry, I forgot to say, qn is the nth rational. So this is where you order the rationals q1, q2, so on and so forth. Because they're countable, you can do that. And so this, if you do horizontal stripes at rational indices, at each rational point, you will have a dense set. So right here will be the image of a dense set Qn, because they're dense. And this construction also makes it for it to be unique. So this is at any rational value. So it's dense at each horizontal slice, at each rational horizontal slice. And because the rationals are dense in 0, 1, this is the product of two dense sets, which is then dense in the product. That's how you do it. Ooh. Noetherian rings. I see. So, you want to know about some Noetherian rings, don't you? So I'll get better at analysis. That's what I'll do. I'll practice. Alright, so if R is Noetherian, if I remember the definition correctly, that just means that for every chain, so ascending chain of ideals, I1, subset of I2, subset of I3, all the way up, there exists an N such that for all M bigger than N, M is equal to IN. So I think that's what Noetherian means. Let me make sure. Noetherian. Noetherian ring. Yep. That's exactly what it is. Right. You've been streaming for 5 hours, so I've it's alright. It's alright. What's up with your numbers? Is that pi? 31415. Yeah, that's pi. Alright. Anyway. For a Noetherian ring, if you create the polynomial ring, suppose there was an infinite ascending chain. So, of ideals. Alright, it goes on forever. Really, it would probably be alright. Oh my god, I can't think of anything to do with this. Why do I always do the Ask Me Maths when I'm extremely tired? No, I still have to de-set up all my stuff. Huh, alright. So, an ideal on the so it's closed under arbitrary multiplication of ideals. Does that mean how about I just project it onto the constants? So you have a polynomial part, which you can multiply by x again, and then you just have an element of the ring right at the end. And so if I separate it out into those parts, because it's an ideal, R prime, what you get here is a different polynomial, call it s of x times x, and plus r times r prime. And so if you project it onto the constant maps, so projection onto the constants, I'll call it pi c, then each of these ideals remain ideals, and you have an infinitely ascending chain of them. I don't know. It's probably a very wrong proof. All right. Noetherian ring, polynomial ring. Let me make sure. Hilbert's basis theorem. Proof. Oh my god, it's Alright, suppose A is a non-finitely generated left ideal. Then by recursion using the axiom of dependent choice, there is a sequence of polynomials such that if Bn is the left ideal, it's the left ideal generated by f0, fn minus 1, then fn is an element of A, removing Bn, is of minimal degree. It is clear that the degree is a non-decreasing sequence of naturals. Let an be the leading coefficient of fn, and let b be the left ideal in R generated by a0, a1, all the way up. Leading coefficient of fn. I almost had the idea. I almost got it. I would have gotten that if given enough time. Yeah. So I think I had the right idea. I just did it wrong. I executed it slightly wrong. So, I think executing something slightly wrong is better than doing it completely wrong. Okay, I'm done.